Hello, everyone. We are in the fourth session of the WebXR conference Comet Room, and I'd like to welcome Fabio Cortez.
Hi, everyone.
For this talk.
Hello.
He will give a presentation on the empowering research and collaboration through WebXR.
Yes.
So let's go.
Let's go. Can you see my screen there?
Looks good.
Perfect. Cool. So let me hide this here. Cool. So hi, everyone. I'm super happy to be here again after 3 years. It was the last time I was at the Global XR conference. It was an amazing experience back then, and I'm sure it will be the same today. So today I'm going to talk about the work we have done in the last year and a half at work. We'll tell you a little bit more about the project we have been doing to empower research and collaboration through WebXR. So a few takeaways of today's presentation would be why WebXR? Why are we using the web? And why do we think web is a good platform, or in my opinion, the best platform to empower collaboration, research, and all these kind of things that are related to science and all other types of projects, exactly or mostly towards research and development, and how can VR improve those ones through the web. We will tell you the story of the prototype we built and all the lessons learned through all this journey, and how we use modern web dev concepts and we merge them with WebXR, with the power of WebXR, to create this amazing tool that we launched a couple of weeks ago. So before starting, a little bit about me. I am Fabio, in case you're wondering where this nice Hispanic accent is coming from. I am Colombian creative developer and generative artist. I like to say that I make computers draw things. I make art and VR and lots of 3D and cool stuff, all with code. So I use code as creative media, and you will see how we are using those kind of things to create content for science and education as well. I am currently working at EPFL. It's a university in the French side of Switzerland, in Lausanne. I work in the laboratory for biomolecular modeling, where with my colleague Luciano, we create virtual and augmented reality tools for chemistry and biology education and research. Essentially, our work is to create open platforms that are accessible to everyone, everywhere. This is our motto, we want to make science open to everyone, everywhere in the world, and creating this open source most of the times, and free tools to empower everyone to use and to get access to modern immersive technologies, especially towards education and research. So with a little bit of context, all this project started 3 years ago with the creation of Molecular Web. It is a website for chemistry and biology education through augmented reality only. It's available, it's for free, an open source project, and it's available on every single device. Essentially, you enter and you will see like 20 or 20 something different apps, small apps that each one of them teaches a basic concept of chemistry and biology. It's web-based, so you don't have to install anything. You just print a few markers with a regular black and white paper. And then as soon as you show the markers towards the camera of your device, it could be your head, your laptop or your phone, your tablet. And then as soon as you show it, you will see 3D content on top of it. This was the first project we created, and it's been already used for thousands of people all over the world. It's available in 9 different languages. It's open source. And with it, we create several different content. Some of them is meant to be consumed through AR or just 3D, interactive 3D on the computers. As part of it, we also created like the virtual modeling kit. Essentially, is the virtual replacement of these plastic tools, these plastic kits that we use at school to create molecules. Maybe you remember those ones. You have these atoms and the spheres, and just like merge them with the sticks to create different types of molecules. We created several different examples for that project, for that tool, and a lot of people were started to reach out to us, asking for more and more content. So at some point we said to ourselves, okay, this is not scaling. So we created a tool so where everyone can create their own immersive content. It's called PDV2AR. Is this one? Essentially, you go there and you can start from a PDF file. For those who are not familiar, a PDF file is essentially a text file that contains the atomic coordinates and all the information of a molecule. And then starting from that, you can create 3 different immersive apps automatically, and it's free. And so essentially, you will receive a link with for consuming or watching this content in AR, in VR as well, and in 3D on the computer. Please keep in mind this project because we will come back to it later. The main question everyone posed to us is, why the web? Why are you creating all this content on the web instead of doing it like natively? Like why not using Unity or Unreal or one of these fancy tools for creating native apps? And the answer is pretty simple. The web is everywhere, and through the web we can create instant content open to anybody, everywhere, because the web is everywhere. I bet that every single device you have has a web browser. Even your TV probably has a web browser. So the web is a nice platform for reaching people all over the world, to reaching people in every single country, open to anyone, anywhere. Also, the web makes a lot of sense if you want to democratize access to education, because people do not have to install or buy expensive hardware to get these tools. And this is also super important to us. And also, being a small team, we want to deliver the apps we create to the most amount of people possible. And through the web, this makes a lot of sense. And this is possible thanks to the WebXR API. For those who are not familiar, the WebXR API is this standard that is implemented in most of the browsers, where you can have access to the sensors that allow you to create an immersive session. It can be either AR or VR. This way, you can create virtual reality or augmented reality experiences that your users and the people can access at one click of distance. Like essentially, just click the link and they are in the experience. No installs, no barriers, no gatekeepers. It's cross-compatible as well. So the same app that you create for your phone can be consumed on a VR headset or on the computer, on any device that supports the WebXR API. It helps to create performant experiences that are more predictable and reliable as well. And also, since this is a standard on the web browser that is implemented in most of them, right? Mostly on Chromium devices, but in the future, when the Apple Vision Pro is out with the Vision OS operating system, it will support WebXR. So I think it's the only platform. We were talking about this last week in Vienna at the OXR conference, in a WebXR meetup we had with all other people that are working in this platform. And we were talking, this is amazing. This is the only platform or the only technology that I would say is forward compatible, because I'm sure we will support the new device that we don't have yet. This device will be launched next year, but it will support WebXR. It's fine. Our app works there, will work there, because it's perfectly predictable, because it's a standard that is implemented or will be implemented in all of the browsers at some point if it's not available there yet. When the first Oculus Quest with hand tracking was launched, that was in the Oculus Quest 2, if I am correct, in 2020, in October 2020, it came with hand tracking. And in my opinion, this changed everything for our work, because thanks to the hand tracking API that comes with the WebXR API, you can have access to the information of 25 points in your hand. So essentially, for each one of these points in your hand, you will have a position and a rotation information that describe how the hand is perceived or seen in the 3D scene. This way, you can have pinch events, so you will know when the user is pinching or grabbing at some object on the scene, or pointing or dragging, even grabbing stuff in virtual reality on the web, which is pretty cool. So we asked ourselves, okay, this is interesting. How can we integrate this with the molecular web, with the first project we did where we have these molecules in AR? So we said, okay, let's make a prototype. Let's just give it a try to this hand tracking stuff. And what can we unlock with this technology? Let's give it a try. What can we do? Maybe real-time collaboration could be an option. And also, we thought back then, maybe having these molecules that we are used to see them, or the scientists or the people who are working in biology and chemistry, they are used to see these 3D structures on a flat screen in 2D. Even if the structure is 3D, they are seeing it in 2D. So maybe with hand tracking and VR, they can manipulate objects in a more natural way. So let's take a look. What can we do with it? So we created this first prototype. You can see that clearly it's 2020 because I'm wearing a mask. So we created this first prototype. This is super basic hand tracking with super simple physics, but it was just a proof of concept. We say, okay, it works. I'm not able to grab things yet, but I can push, I can move things, and I can see it and manipulate molecules and these kind of things in a more natural way. This was the first prototype we built in December 2020. And as you can see, back then it was amazing. It blew our minds. And we said, okay, this is super promising. What can we do to improve this? Let's go a little bit further. So what else can we do with this? So we said, okay, let's add some more fancy physics. So we added this library for the web that is called Canon.js, that has rigid body dynamics. So it's pretty simple physics. And with the hand tracking, we can, instead of pushing things, let's try to grab things using the pinch event. As you can see here, it's Luciano, my colleague and friend, making a knot with molecules. This was the first test we did with the physics, and also we improved the visualization of the hands. As you can see, we were now rendering a proper hand instead of just these random points on these 25 points I told you before. Also, we ask ourselves, okay, now we know it works. We can grab things in VR. Now the question is it actually useful? How can I compare a task that I can do on a screen or in a regular screen, flat, versus what I do in VR? So we created another set of tests, like this one. Slow down the volume. Like this one, where we were trying to compare how long does it take for a scientist or for a person who is working in biology to pass this molecule through a carbon nanotube in virtual reality. As you can see, 11 seconds, 12 seconds? It was immediate, and we didn't have to teach the people how to use it, because they can handle the objects in a more natural way since they're using their hands. Everyone already know how to use their hands. So this was a major improvement in the time that took people to pass these molecules through a nanotube. It was like the flat screen, I think it was 2 minutes or something like that. And as you could see, was 10 seconds in virtual reality. Next question we posed ourselves: okay, can we make something with 2 people at once in the same session, so they can collaborate, create like passing this nanotube, this molecule through the nanotube? So we say, okay, let's give it a try. And we didn't know back then how to implement the multi-user stuff, how to make collaboration. There were not much information available on the web, and not much to see as an example of this kind of thing. So we went for peer-to-peer communication. We did like a super simple app, and here 2 people connected to the same session, and you can see one is moving the nanotube, so the other one can pass the molecule inside. We also did this test, and here you can see, I think it's 15 seconds or 20 seconds or something like that. And when we did the same test for 2 people doing this kind of task on a computer, was a couple of minutes or even 4 or 5 minutes at some point. So there was a huge improvement in this type of collaboration. But then there were significant scalability challenges and technical challenges when we wanted to do this kind of collaboration, because we were using peer-to-peer communication. Essentially, we created 2 different web apps, one for the sender, one for the receiver, and we were running the physics and all the collisions on one of them, like the sender, let's say, like was the head of the session, let's say. And then the other one was only seeing like a mirror of what the other one was seeing and sending the events to the other one, and everything was processed in one of the clients, but still a client side, but still one of the 2 of them. So there were the single source of truth were the sender. And then we ask ourselves, okay, what if we want to add 1 or 2 or 3 more people? Then it's really a problem, because peer-to-peer networks are really, really hard to scale. The complexity of the implementation increases exponentially with the amount of people connected. And then while we were doing this kind of experiments and tests, we already knew or wanted lots of new features, and they were probably super difficult to implement using peer-to-peer communication. So we said, okay, let's give it a try to something else. And then we decided to go with WebSockets. And so this way, using the WebSocket technology for the WebXR multi-user platform application, you can have low latency and bidirectional event-based systems. We are using Socket.io. This is an open source, amazing open source library that has a client and a server implementation. So there's like 2 different parts of the API, one for the server, one for the client. So essentially, this way, there's one single source of truth that is the server that routes and broadcasts everything to every single user that is connected. Also, thanks to using this library and this tool, we could have several features that were otherwise would have been extremely hard to implement by hand, like automatic reconnection, like when a user for some reason disconnects, either lose connection because lack of internet connection, or just by mistake disconnect or reload the page or something like that. We also have the acknowledgement. So there are some cases where I send a message to the client or the client to the server where I want a confirmation or an information that needs to be sent back. It's also implemented by default in Socket.io through WebSockets, so it's also pretty cool. And broadcasting was also out of the box. So we said, okay, let's go with WebSockets. Let's try and see how it works. But then we found another problem, and it was like the fact that we wanted to have these sessions in person instead of being remote yet. You will see that we ended up with that problem, but later. Back then, we thought, okay, we want to create this tool where people can collaborate, but in the same physical space. And as you may know, these devices are not meant for that. The virtual reality devices, like the Oculus Quest 2, now the 3 or the number 1, were meant or are meant for being used like one at a time, one person at a time in a single physical space. So it was quite a challenge to figure out how can we position multiple people in one same physical space, but also having the chance of making it as tight as possible to the digital space. So they are in the same physical space, but also in the same physical space, digital space. It's the same. We wanted to make to have them both in the same space. So it was difficult. We had several ideas. We did a lot of tests. At the beginning, we draw these small circles on the environment, in the virtual reality environment, and we try to place the people immediately there. As soon as they get in VR, I placed every single user in one of these points, and we were trying to stand or to position the people so they were standing on top of that point, virtual and physical, in the same space. So we measure with the tape and all the things, and it didn't work. It never worked. It was extremely hard to do it. So we found another workaround, and it was creating the same guardian in Oculus. For those who are familiar with it, we created the same guardian for every single device, starting at the same point. So the key was the center, this black circle with lines in the middle. So we started creating all the guardians there. This way, all the local coordinates for every single user were the same. And then we had to position one by one, every person one by one, and then tell the person, okay, now go see your hands, look which color is it, and go stand in the dot that corresponds to the same color. And that way, one by one, we managed to have like 6 or 7 people at once in the same space. This positioning thing was very important for the things we were aiming. Later on, I will show you how it works. But before testing with users in this kind of setup, we need to add 3D content. So we started adding 3D models. As here you can see, we added a lot of 3D models. Some of them we found them online. Some of them we created them in one of the tools we have. So we have this first room with this preset content. As you can see, here is a cell with a lot of detail. It's pretty amazing when you see it in VR. Also the chromosome, it's pretty cool. So once we added the 3D content for the room, we say, okay, let's try with people. Let's see how it works. Here you can see a screenshot of one of the first sessions we had. Clearly, it didn't work pretty well because both of them were with the same color, and it shouldn't be like that. But it was the first test. We saw that people could connect, and they were handling and manipulating objects in a supernatural way, and it was working pretty well with the level of detail in the models and the communication that were super good for the meetings we were aiming. But then for 2 people, it was working pretty well. But then when we added more people to the session, then the performance started dropping a lot. So as soon as there were 3 or 4 or 5 people, it crashed essentially. So it was super slow, lagging. It was really bad. So then the next challenge was, how can we maintain a decent frame rate? In the Quest devices or in WebXR, we try to aim 90 FPS, so 90 frames per second, which is pretty fluid. But it was impossible with the setup we had, with the code base we had. It was impossible. So we created this small dummy setup, like fake users that were broadcasting coordinates and broadcasting everything. So here you can see how they were kind of dancing and moving their hands in a super weird way. It's not real people, are dummies. We created this our own dummy system for play again, to try to see up to how many people we can try. And immediately we reached the limit. It was 3 or 4 back then. So we decided to render the content for each user, the content or the things I'm grabbing, my own hands, all the things that are from myself, from my point of view, I will render them at 90 frames per second. But all the other things, all the information that is coming from the other users, from the elements that someone else is grabbing, the hands, the movement of every single other person, all the other animations, we are going to reduce the frame rate of them up to a decent level, but not as fast as mine, because I want my hands to move as fast as I am really moving my hands. But if I see someone else's hands moving a little bit slowly, the brain, it's fine. I mean, the brain understands, and it's pretty well. Here you can see how it looks like at 90 frames per second, grabbing the skeleton and the circulatory system. And it works pretty well also for grabbing the things, to scaling. And so this way we did like a small type of batch rendering. So we were rendering the content that was the incoming content from the other users at a different speed, at a different frame rate. And it solved our challenge, or at least this one of the frame rate. It was also another lesson we learned along the way. Here you can see how we can render pretty smoothly this type of content that were from my own side. And then we had the first test with real users, and this was in Bern in August 2022, last year. There was a chemistry and biology conference, and here you can see that there is one of the scientists presenting his work and the structure he resolved. He's explaining there to other scientists that were there in the same physical space with the setup I told you before. And here he's pointing and seeing, explaining to his other colleagues and the other scientists the work he was doing. There was also a slide in the wall. For this one, slow the volume again. For this one, we were also presenting in a big screen with a projector in the back. So the people that were not in VR were also seeing what they were seeing, but not from this first point, like first person view, first person view, but rather in my computer that I was broadcasting them what they were seeing from a 3D perspective. I will show you later how it works, because the next step was the UI, as you can imagine. So we fixed all the things for the VR or the visualization 3D point of view, but then the sessions were super limited to only to the people that were standing in the place. So we said, okay, we should have like a user interface that allow people to see it from the computer or from the phone, and then add more 3D models, block users, add multiple 3D elements, probably an admin panel, maybe scaling elements from the UI. And what if I want some people to grab or not the things? Because you can imagine everyone super excited seeing the molecules and at once, and all of them trying to grab the molecules all at once. It was a mess. And also trying to reduce the technical debt as much as possible, so there were room for future features. And we said, okay, this is too much. Right now, the architecture of the app is not meant for this kind of things. It's not scaling. It's really complicated. It's just not working, because there are three parts from the app: the server side, the 3D, and the UI. And which data is shared between the 3D and the UI? Which is the single source of truth? Where am I emitting and listening the server events from the users and the content that is being sent or received? It's a mess. It's all merged from one side, from the other, and there's a lot of information that is duplicated. It's extremely complicated. We need to make it reactive. We need to have a different architecture that allows us to scale, because otherwise it will just die. It will crash. It will never work. So we decided to add the Redux, this state management library for the web. It's from the modern web dev that I was telling you before. We also implemented a socket middleware, so it was a single source of truth for handling all the events that were coming from the server. All the information that was being broadcasted was in this socket middleware. And for the UI, we added React, the UI library from Facebook. So the UI was reactive as well. And then how can we make reactive the 3D? It works in a super different way than the regular 2D user interfaces. So for that, we created some Redux selectors. Basically, they are functions that return the state or a part of the state. For example, the users. The users were an information that was shared within the 3D and the UI. From the 3D point of view, the user's information was for the render, to create the representation of the person, the face, where the person is looking, where are the hands, which is the color, how is he or she moving the hands, and all those kind of things. And from the UI perspective, the user information was just to say the name, the color, and all the permission this person has. So essentially, it was kind of the same information, but used for different purposes. So with the selectors, we created this reactive 3D, in the sense that these Redux selectors are only recalculated when information changes. So it makes all the other things that on top of that reactive as well. So essentially, the lesson we learned here was divide and conquer, separate concerns, divide the concerns, and make them like two different mini apps, the 3D and the UI, completely independent between them, and all depending from the global state that was also coming from the single source of truth that was the server. We did that upgrade, like the refactor. It took us like a couple of months. It was a lot of work, but it paid off. It was incredible how it paid off. A couple of months after that, we were at the European Molecular Biology Laboratory in Heidelberg in Germany, showcasing the app. Here you can see one picture of one of the demos we held there. Up to 45 people tried the tool that day in different sessions, from the headset, from the computer, from an iPad. It was really, really cool. So we saw that, okay, this paid off. It worked. So we added a couple of more improvements. And a few months later, we were in the EPFL Open Days in the university where we work. Let me stick the volume. Oh, sorry. Okay, is this okay? Okay, come on. Here you can see the session we held. One of the sessions we held at the EPFL Open Days. This is one day that is every 3 years, I think, where the university opened the doors to the community from the city and from all the country, all Switzerland, where people can come and see what we are doing, all the science we are creating, and all the tools and the things we are building. And we held on those 2 days like 20 sessions, I think, up to 90 or almost 100 people tried in several different sessions. Here you can see one of my colleagues explaining the work we do at the lab to 8 people from the community in Lausanne. It was one of the first tests we did on the wild, and it was amazing. We learned a lot from the tool, from the people, from all the things that we needed to improve. But all those tests were with the same people, with the people in the same physical space. And we asked ourselves, okay, what if someone wants to connect in a remote session? And we said, okay, let's add an audio channel. We already learned that the peer-to-peer network or the peer-to-peer protocol was problematic in terms of scale. So we decided to go with the SFU, the Selective Forwarding Unit. We used MediaSoup, which is a client and server-side library based on WebRTC. Essentially, every single client, which means every single user, are connected to the server. And then the server decides which streams want to send to which user. It's highly scalable, as you can imagine. And it also helped us to be prepared for the next feature, which were the rooms. We wanted to create or to have a platform that can handle multiple sessions at once, sometimes with preset content that we create and also open to anyone, anywhere. So this is mostly a server concept, I would say, because every single client or a user, they don't know and they don't care. They shouldn't care about other sessions that are being held in parallel. So from the server point of view, we created this room concept where we select or people connect, let's say, to a single room, and then we broadcast or show the content on the render or the things only to those people, and also with the SFU protocol, or no protocol, no, the network topology, that's the word. We can see, or people were going to only listen the people that were in the same room. Like we tried to think, okay, let's make the audio before the rooms, but make it in a way that it will scale when we added the rooms, you know. And here you can see a screenshot from all the rooms we have right now with some preset content. Each one of them, except the empty room, of course, has some different 3D models from different topics or different areas of chemistry and biology. We have materials and crystals. We have some structural biology models, and the cryotomography, which was the last one we added. We'll take a look later how it works. We launched the tool a couple of weeks ago. And there are some people already using it in several places around the world. And there are a couple of screenshots or pictures from some users in Argentina that are already using the tool for their lectures and for some classes with students and stuff like that. We have received very good feedback from the people. Mostly the students say that they understand or perceive the concept in a super different way when they can see and manipulate things naturally in virtual reality, either with hands or controllers. It works with both. So yeah, this is pretty much what I have right now for you, but let's take a look how it works. So now I'm going to create a session so you can see how the app works. This is Molecular Web. This is the Molecular Web XR. This is the tool. As soon as you enter, you will see a couple of buttons to create a room or join a room. If someone shares the code with you, you can also just, if you don't want to create a room, you can just, you are one click away from giving it a try. So if you click there, you will see that in the computer, you can just walk with WASD, like if it were a first-person shooter, like a game. And then here you can see some context, some help and some context. If your device supports VR, you will see this button. You will enter in a virtual reality session where you can go inside and grab some of the things. In this sample room, we have a couple of some samples from the different rooms we have. I'm going to exit and I'm going to create a room, and I will invite my friend and colleague Luciano, who is in Switzerland. I'm in Spain right now, in the beautiful city of Valencia. My colleague, friend is in Lausanne, in Switzerland, and he's going to connect, and you will see how it looks like on the wild. I hope this works. These live demos are always crazy. I hope this works pretty well. So I'm going to create a room from cryo-electron tomography. You can see the 3D models here, and this is the admin panel. I will send the code here. If you click here, I will send the code to Luciano. Okay, so the code is BOXJ. There it goes. So in the meantime, while he connects, when you click this button, you will see the codes. There are two codes, one for the active users and one for the guests. It's like having people in the meeting or just guests, people who are going to only listen. For example, for a lecture or a webinar, it makes a lot of sense that way. And then you can invite other speakers if you want, or just have a meeting in virtual reality. You can do both, or even a mix of them. Here you will see a list of users that are connected. Right now, we don't have any other users, so it's just me. Now here we see Luciano. He's there. Hello, Luciano. He's there. Here you can see that there is this switch that says can grab or cannot grab. This way I can enable or disable a user for grabbing or not being able to grab content. This is especially useful if you are having a class with kids and you don't want a mess in your class. You probably want to not let them grab things all at once. Hello, Luciano. We're seeing you. Okay, let me walk a little bit here. Still learning how to move in first-person shooters. Okay, here is what you can see. You can walk if you enter to from your phone. This is the coronavirus SARS-CoV-2 model. This is one of the coolest one we have. You can even walk inside, and if you were in VR, you would be walking around it. It's pretty amazing. Here you can see there is also a slide. Most of the rooms have a slide where you can see like a small explanation, our contact details if you want to reach out to us. This is how it looks like, and then here is also the elements menu where you can add more elements. You have to create them in PDV2AR, the tool I told you at the beginning of the talk, where you can create 3D content on demand from our tool, and then you will receive an email with the URL of the 3D model, and then you just paste here the name and submit, and then you will see the model here. Yeah, essentially also, well, you can also here click to block an element to not be grabbed, or you can delete content, you can recenter, scale up, scale down, lots of other things. If the scene is already a mess because many people grab everything, you can just click reset and everything will be back to the default state. If you open the link, molecularwebxr.org, in your phone or your computer, and then you enter with SVOI, you will be able to walk like I'm doing. If you enter from your phone, you will see a small joystick on the left, I guess. Yes, left, on the left bottom, and then you will be able to walk around the scene like I'm doing here right now. Here is my colleague Luciano walking around. Hello, Luciano. So yeah, this is how it looks like. If you are not in the same space, in the users menu, you can enable the audio channel. and then you will be able to talk through the system. We left this as optional because if you want to have the session in the same physical space, then well, audio doesn't make much sense. Cool. So I guess that's it from here. I will close the session. Luciano, thanks a lot. Cheers. And then you click. He left, and the session is closed. When you have the code, you just enter here your name, the room ID, and you just join. So yeah, let's go back to the presentation. Oh, yes, here. This work was funded by the Swiss National Science Foundation and the Hasler Foundation at the beginning. All the first prototypes were funded by them when we started this project, and then we got a grant from the National Science Foundation to keep working on this and to create the actual product, the actual final product that you see. So that we launched a couple of weeks ago. Also, I would like to acknowledge and say thanks to the amazing WebXR community. This WebVR, web-based augmented and virtual reality platform or technology is very much community-driven. This is something I also like a lot. I love it. It's pretty amazing. We have a Discord channel, and people are super friendly. So if you are more interested in to know more, to get in touch, you can look for it, and it's pretty amazing. It's pretty cool. Lots of open source, lots of friends. It's a very nice community. Here, just before finishing, is a picture of the big team behind Molecular Web in a meeting we had at Le Playat in Switzerland last year. It was a bit cold, but it was pretty nice, that meeting. So yeah, that's pretty much it from me. If you want to take a look to the app, it's molecularwebxr.org. And if you want to learn more from our projects, you can enter to the link tree, Molecular Web. There are lots of other things from us, other tools we have created. All of them are oriented to virtual and augmented reality for science and education. And if you follow us on Twitter, and in my case as well on Instagram, it's Fabio J. Cortez. We are posting constantly lots of content and all the experiments we're working on. So yeah, that's pretty much it from me. You have questions, comments?
Right. Yeah. Thank you very much, Fabio. First of all, for the presentation. Yeah, very interesting. Collaboration system for science. Yeah, it's research. Yeah, in science. I guess. I've never heard of that one, but it's interesting focus of like for the research community. So my first question is just how do you compare your system to like other web social web systems, like you maybe know Mozilla Hubs.
Mozilla Hubs, yes.
Right, and there are also many others, right?
Yeah, there are some other tools. We are mostly focused on research and collaboration. So most of the features we have are oriented or having this in mind, like lectures, webinars where people can create their own 3D content oriented to biology and chemistry, and they can add those elements there. So that's one of the things, like we can dynamically add chemistry and biology content to the app. Also, we are free, and some of them are not free. We are a small team, as you could see, too. So we have limited resources. So as of now, we are only allowing the sessions up to 15 minutes. If someone wants more than 15 minutes in one session, well, you can reach out to us and we can talk about it. We can discuss and we can see. We also have a lot of preset content, which is one thing that I think is a killer difference between us and the other social platforms, because then there you just enter to talk. I mean, it's amazing. It's nice for social purposes. It's amazing for a meetup, for a webinar, for something like that. But if you want to create a class or a lesson, a webinar or something like that, that's a bit more complicated. And also we have this 3D preset content as well from different concepts of chemistry and biology. Some things like that are also nice. Also, those kind of systems are hard to set up, are really, really hard. I mean, they are not meant for that. It's not that it's bad, because it's not. It's that they are not meant for that, for having the sessions in the same physical space. which is one thing that at first I thought it doesn't make sense. Why if I have virtual reality, why do I want to have been in the same physical space? But then with all the events I show you, all the events from the scientific community, it made a lot of sense to all of them. It's crazy. I mean, this is one of the biggest lessons I learned in this project. Like all the things I thought from before were wrong, and then you learn
Yes.
testing with the users on the way. It's amazing.
Definitely, yeah. There are many challenges, and it's great that you provide this as a foundation for others to develop their virtual classrooms and research collaboration. Right. So we didn't get more questions from the audience on YouTube, but I wish you the best of luck for
Cool.
the
Thank you so
further
much.
developments.
Awesome.
It's very interesting, and I would say we can close the session now.
Cool.
So thanks
Great.
again.
Thank you so much. See you soon.
See you soon.
Ciao.
Bye.